So we are going to be reviewing our first chapters here. So this first one, we're working on composition of functions. So again, as a reminder, this says take f of x, so right here, and replace it in g of x. So g of f of x would equal x minus 4 squared minus 2. And then the other way around, we're going to be taking our g of x and putting it into our f of x. So this would be x squared plus 2. We're replacing our x, minus 4. So that's really x squared minus 2. And that's our f of g of x. So the second one here, if 5 minus 3x and x squared plus 4, find g of f of x. So again, our f of x is this inside one. So here's our, oops, these both say that. Let's switch this to f right here. So let's say this is our f of x. So we're going to take this and replace our x with it. So it'd be 5 minus 3 times x squared plus 4. And then we could distribute 5 minus 3x squared minus 12. So we have negative 7 minus 3x squared. So now this one, graph the composite of g of f of x squared and find the domain. All right, and these kind of don't match up. Sorry about that, guys. So let's say we're going to graph this one. Well, what do we know? It's a parabola that's moved down 2. So 1, 2. So here is our parabola moved down 2. So our domain keeps getting wider, so it's all reals. And then our range, y is greater than or equal to 2. And find the domain of the square root of x minus 3. Well, I know this is a square root one, which starts here. Minus 3 moves it to the right. And you could always graph this too. 1, 2, 3. All right, so move to the right 3. So then this one, our x values, our domain, x has to be greater than or equal to 3. And then our range, it's always above 0. So if you remember what the inverse is, it's switching our x and y. So x equals 2y minus 3. And then we have to solve for y. So x plus 3 equals 2y divided by 2. So x plus 3 divided by 2 equals, I'm going to use our inverse notation with that negative 1. So again, find the inverse. So let's switch it. So x equals y squared plus 4 minus 4 minus 4. X minus 4 equals y squared. And to get rid of a square root, squared, we take the square root. But we have to remember it's plus or minus. And then I'll switch this. This is our inverse. So I'll use that inverse notation. And the hardest ones here are that fractions. But again, that first step, let's switch our x and y. And then we can say, well, let's get rid of our fractions. So if we fraction bust, multiply times y minus 5. So x times y minus 5 equals, well, it would reduce out here. So that's just 2y. When we multiply, again, I'm multiplying this into everything. And now we distribute. So xy minus 5x equals 2y. Let's get the y's on the same side. So we have negative 5x equals 2y minus xy. Well, if I factor out a y, this would be y times 2 minus x. And then I have to divide by 2 minus x to get y by itself. So we have negative 5x over 2 minus x equals our inverse. Now those division ones are probably the trickiest there. Okay, so the next part on chapter 1 is transformations. So let's see. I know that this is a square root to the right 3. And this is an x times 2, so this is y times 2 values. But I can also just make a table. So let's see. Well, I could start plugging things in, but I knew it moved to the right 3. So I'm going to start with 3. So 3 minus 3 is 0. The square root of 0 is 0 times 2 is 0. So I know 1, 2, 3. And what if I put in a 4? 4 minus 3 is 1. Square root of 1 is 1 times 2 is 2. So 4, 2. If I did a 5, well, you can't take a nice square root of that. So what's another number under here that I could take a square root of would be 4. But to be 4, x would have to be 7. So 7 minus 3 is 4. Square root of 4 is 2. 2 times 2 is 4. So this was 4, 5, 6, 7, 1, 2, 3, 4. And we have our graph. So let's describe our transformation on number 6 here. So x cubed to right here. Well, I know that this moves up 2. Minus 3 moves to the right 3. Negative, it reflects it. So that would flip it down. And the times 2, that's our y values, times 2. Because again, it's not directly next to our x, so it's the y. All right, so here is a graph. It has a min and max. So graph on the same one, x minus 1 plus 3.5. So again, what are our transformations? To the right 1, up 1.5. So to the right 1, up 1.5, and check what this is counting by. So to the, oh, that's not to the right 1. It's counting by 0.5. So to the right 1, up 1.5. And this one is at 1.5, so 2.5. All right. And then if I was to take this one to the right 1 would be 2, up 1.5, would be at 2. So this I know goes like this. And again, I can move this one to the right 1, up 1.5. So the scale's tricky in that. So the coordinates of the max and min. All right, well, to the right 1 would be 1, up 1.5. And to the right 1 would be 2. And up 1.5 would be 2. So this is our, so it was talking about our min here and our max there. So finding critical notation, and this says use interval notation. When is it increasing or decreasing? Is it odd or even? Well, I'm going to say it's even because you can fold it in half. Again, odd is if you can rotate 180. So where is it increase? So if I was to highlight this, it's increasing and increasing. And again, interval notation, -1, -2, -3 to 0. And then 1, 2, 3 to 7. And then where is it decreasing? Let's see. Well, it's decreasing here and here. So what is that? That's between 0 and 3 and -7 and -3. Because again, we always use our x values. So end behavior. You could graph this, or if you guys remember, we look at our highest exponent, which is odd, and it's negative. So I know that it looks like this. So as x gets bigger, what happens to y? Well, y goes down. And as x gets smaller, as we move to the left, y goes to positive infinity. And that's the end of chapter 1.